Um, okay. Now we have Léore Bensabath. Is that correct? And she'll be presenting text-driven 3D hand motion generation from sign language data. Thank you.
All right, so hi everyone. This is a bit of a broader vision problem than just like sign language generation, but it still has application within the sign language field. And this is a work that has been done in collaboration with Matis Petrovic and Gulvarol. All right, so the task we're trying to solve is generating 3D hand motion using text description of the motion. So an example of the task. So an input could be, for instance, both hands start as feet. The right hand's little finger edge is near the left hand thumb edge, and they move apart, opening into spread fingers. And the output should be a 3D motion that fits the description. So this would be a valid generation. So our main contribution is that we provide a pipeline to build a data set that allows us to train a model that will be able to perform the task. So the data set we build is called BabSL 3DT, and it's a data set including 3D motion associated with text description. So first, we need to extract the 3D motions. And to do so, we're going to leverage the BabSL video dataset, which is a BSL dataset that uses television broadcast videos that has been automatically annotated with gloss names. So you have on the screen an example, a sample from the BabSL dataset for the sign show. And from these BabSL gloss samples, we're going to extract the 3D motion using off-the-shelf 3D pose estimation models. So we use a combination of known 3D pose estimation model. First one is called SimplerX. It's a full body pose estimation, but the hands are not accurate enough for in SimplerX. So we combine it with the known hammer model, which is only dedicated for the hand, but is a lot more accurate. And we combine the output of both these models through some optimization. And now for a given sign, for like a given sign name, we have a 3D motion, but we still don't have an actual textual description of the motion. So how do we use both these elements to get this textual description is going to be the next part. So to get them, we use the SignBank BSL dictionary, which is a BSL dictionary that for a sign name, so still with our example of the sign show, it's going to associate a sign video, and also a bunch of phonology information about the sign, including the hand shapes, the location of the sign, and the part of the hands interacting with the body part, which is the location where the sign happens. And also, as you can see in blue, some more broader information about the sign, like here, for instance, that the sign is double-handed and symmetrical. So this is very valuable information, but first, it's still bullet point information. It's not a continuous English text description. And also, it's not exhaustive because it mainly concerns the initial and final state of the sign, but it doesn't really describe the motion happening in the middle to go from the initial state to the final state. All right, so to mitigate the later issue, we create a pipeline that is called hand motion script. and it's directly derived from the POSSCRIPT model. And this is what it consists in. So it's performed frame by frame on the frame 3D poses that we extracted. And for each frame, it's going to derive a code, like an English code, for two characteristics. First, the distance between the hands and the relevant body part, that is the location of the sign that we got from the sign bank phonology information. And second, we're also going to get a code for the palm orientation of the hand. And we get this code by defining some numerical distance and angle threshold that are fixed and that we define beforehand. So here, for instance, for the sign show, you will have the sequence that's the distance between the hand and the head, which is the sign location, is first close and then medium distance. Now with both the set of information, the phonology and the hand motion script output, we can feed them to an LLM, in our case, Gemini 2.5. And we ask it to generate English textual description. So here, for instance, for a sign, you'll have the information within the description that the sign, like the motion starts with index finger extended and palms facing inward, position near the eyes, and that they move away from the face, spreading all fingers. So you see it's a combination of information from sign bank and hand motion script. So now this text description comes from the sign bank videos, but we can associate them to our BubSL 3D motion based on the gloss names that are the labels of the BubSL motions. All right, one issue remaining is it's choosing the right sign variant. So here, for instance, for our sign show, so you can have a sign for the verb show and a sign for the name show. But from the BubSL information, from the BubSL labels, you just know that the label is show. So we don't know which variant to assign from SignBank. So the way we do it is that we train a model called TMR, which is a VAE, so a variational autoencoder model. So it's like CLIP, but using 3D motions as input instead of images. And what it does is that it allows us to bring into a common embedding space. Like we get the embedding representation of our 3D motion, such that two motions that are more similar will be closer together within the embedding space, and two motions that are more different will be further away in the embedding space. And so we pick the variant from SignBank that is closer to our BubSL sample inside the embedding space. All right, so now we have our dataset build. Just for some numbers, the specificity of our pipeline is that it's fully automated. So in terms of scale, we can do a lot bigger than the kind of dataset that existed before, that includes either video or motion as shaded with a text description. And so our dataset is about 1.3 million samples against a few thousands for the previous datasets. The trade-off is that it's automatically annotated, so it's a lot more noisy, but our hypothesis is that the scale makes up for the noise to some extent. So some qualitative results. So first, we train a diffusion model using this dataset. We don't contribute anything specifically new to the model, so I'm not going to detail it. And so these are some examples of generation. So here the text is, part of the text are that the index and middle fingers are extended and crossed, and that the palm faces outward. And so I'm going to show first the Signbank video from which this text is extracted, and then the ground truth motion of Bob SL, and then the generating motion. All right, quickly another example. I'm not going to read the text, but it's the same. You can see visually that it looks alike. All right, and one last thing is that we can also, to some extent, do some transfer using the text description from other datasets. So this is a text description from an ASL dataset, and you can see that. So to the left, you'll have the to the right, you'll have the ground truth. The baseline is trained using the ASL dataset, and then our model is trained using our contributed dataset. And you will see that our model looks better. And, all right, so I'm over with my time. And I'll take some questions if we have time. Or later.
One question. Oh. Anybody has a question? Ollie?
Yeah. For the variants that don't match the canonical form in Signbank, do you still include those in the data set, or do you keep them, or is it just curated?
So the question is, if I don't have the same variant...
So you have the matching to the Signbank variant.
Yes.
For the ones that don't match the Signbank variant, do you go with the just what your hand motion script outputs as the ground truth?
No, if I don't have a match at all, I discard the sample.
So those like natural variants they're curated out of the data set then?
Yes. Actually, that's a flow from the dataset, which is that if there is a Bob SL variant that is not included in Signbank, and like in Signbank, there is just this one variant and it's different from ours, then we won't be able at this point to distinguish that it's so far away in the embedding space that it's not the same variant. So we'll assume that if there is this variant of the sign in our Bob SL dataset, it's going to be included in Signbank. But if it's a gloss that is not at all present in the Signbank data, like dictionary, because it doesn't have all the gloss that are represented in Bob SL, then we'll just discard the Bob SL samples.
Okay, thank you.
Okay, let's thank Léore.
Thank you very much.